All right, here's how you do questions 1 and 2. Okay, they're very similar. So in this problem number 1, they're asking you what is the distance between Jupiter and Saturn if the Jupiter is now, and the video that I'm making, I'm using different numbers. So let me give you a picture of what is this problem saying. So here's the sun, here's Jupiter. Imagine the distance between the sun and Jupiter is 6.4 times 10 to the 9th power. Remember, this number is written in scientific notation, which is basically the template that I have up here. We are writing large numbers in a different way. Okay, 6.4, you can see that will be the big box here. It's a number between 1 and 10. I forgot to write that down. So let me put it in. This is a number between 1 and 10. So 6.4 will fit in the big box. And times 10 to the 9th power. So when the exponent is positive, this means this is a big number, very large number. So the distance between Jupiter and the sun, 6.4 times 10 to the 9th power miles. Saturn is a little bit farther from the sun, 8.3 times 10 to the 9th power. Okay, the question they ask you, number 1, is what is the distance between Jupiter and Saturn? See, what is the approximate distance between Jupiter and Saturn? Now, when you are working with numbers in scientific notation and you want to add or subtract them, you need to make sure that the power of 10, which is basically what I have here, the power of 10 have the same exponent. Because if they don't have the same exponent, you're going to have to do something extra before you add or subtract. Now, since I want to find the difference between, I want to find the distance between Jupiter and Saturn, okay, the only thing I have to do is subtract the distance of Saturn minus the distance of Jupiter, but I don't need to put the powers of 10 if they're the same exponent. So basically, I just work with the 8.3, okay. I'm going to subtract, let me move this out of the way, 8.3 subtract, let me clear that up again, 8.3 subtract 6.4. And you can see I get 1.9. So the distance between Jupiter and Saturn is 1.9 times 10 to the 9th power. Okay, so the way I did this problem is how you would do number 1. Okay, here we go with number 2 now. So in question number 2, we are comparing the size of the planet Mars and the planet Mercury. And Mars is a lot bigger than Mercury, and the way we measure the size of the planet is in cubic miles. So the question in problem number 2 is asking you what is the difference in volume of Mars and Mercury. The word difference means subtraction. Again, when you are working with numbers and scientific notation, you need to make sure that the exponent of the power of 10, so this here, and this one here, oh, I forgot the exponent here. Let me write it down now. This was to the 10th power 2. Okay, so the exponent of the powers of 10, they are the same. If they are the same, then basically what you have to do, the word difference means subtraction. You're going to take the calculator, okay, and you're going to subtract 7, take away 1.5. Okay, that's all what you have to do. 7, take away 1.5. And let me show you my calculator. There it is. So the difference between the size, the volume of each of these planets is going to be, final answer, is going to be 5.5 because I subtracted the 7 and the 1.5 times 10 to the 10th power. If your numbers were written in scientific notation, your final answer also has to be written in scientific notation. And that's how you do question number 2. Let's go question 3. All right, in question 3, they told you that the Earth, again, I'm changing the numbers of the problem, but the problem that I'm describing with different numbers is basically the same type of problem as you're going to have to answer. They tell you that the Earth is 8.2 times 10 to the 7 power miles away from the sun. Mars is 5.03 times 10 to the 7 power miles from Earth. They're asking you what is the distance of Mars from the sun. Okay, so when you read the problem, it's basically this picture I did here. And if you see, basically, if I want to know how far away is Mars from the sun, I'm going to have to add the distance from Mars to Earth and the distance from Earth to the sun. But before I add, I need to make sure that the powers of 10 have the same exponent. So this here says 10 to the 7th power. This one here says 10 to the 7th power. We do have the same exponent. So the only thing you're going to have to do is add the numbers that are not the power 10. In other words, I'm going to take 5.03 and I'm going to add the 8.2. See, the numbers that are not powers of 10, the decimals, that those numbers are in between 1 and 10 because these two numbers were written in scientific notation. And when I add them, I get 13.23. So let me write that down. 13.23 times 10 to the 7 power miles. However, my answer is not written in scientific notation because to be a number to be in scientific notation, this number here that I'm going to highlight in yellow, this number here, 13.23, must be a number between 1 and 10. See, if I write 13.23 in here, this number is not between 1 and 10, which is the requirement to be a number in scientific notation. So what we're going to do, we're going to fix it. How do we fix it? I'm going to take the decimal point of 13.23 and I'm going to move it 1 time to the left. Now it's going to be here. So my new number now is 1.323. See, that number is between 1 and 10 times 10. Now, the original exponent of the power 10 was 7, but because I move it 1 time to the left, okay, what we do is we add 1 more to the original exponent. So now it will be to the 8th power. And that will be my final answer for question number 3. We're going to do something similar in question 4. In question number 4, we have a different scenario. Now we're comparing the population of two countries, India and Pakistan. Again, I'm going to change the numbers, all right? But the problem is done in the same way. Okay, so let's say that the population of India is, I'm making this up, okay, 2.3 times 10 to the 9th power people. All right, so that's a lot of people. And then the population of Pakistan is, again, I'm changing the numbers, but the process is done the same way, okay, is 4.1 times 10 to the 8th power people. Okay. Now, what they're asking you is, what is the total population, okay, of these two countries? So how many people are there between the two countries together? Now, to add or subtract numbers in scientific notation, we need to make sure that the powers of 10, which I'm going to highlight again, the powers of 10, they have the same exponent. Okay. However, they don't have the same exponent. Okay, India, the power 10 has exponent 9. Pakistan, the exponent of the power 10 is 8. So for me to be able to add these two numbers in scientific notation, I need to make them the same exponent. The power 10 must be the same exponent. What I suggest you do is take the smaller exponent, 10 to the 8 power, and the scientific notation with the smaller exponent, 4.1 times 10 to the 8 power, that's the one that I suggest you fix. So make it to exponent 9, like in India. Now, how do we do that? So let me put it here, 4.1 times 10 to the 8 power. What we're going to do is we're going to move the decimal point one time to the left. So now we're going to have it here. So now it's going to be 0.41 times 10. And when you fix the number or you move the decimal point one time to the left, what you're really doing is you're adding 1 to the original exponent. Okay, and now your new number is going to be 0.41 times 10 to the 9th power for the population of Pakistan. And when they both have the same exponent as the power 10, what I'm going to do is I'm going to call my calculator and I'm going to add only the numbers that are not powers of 10. So from India, I'm going to take 2.3 and I'm going to add the population of Pakistan, but the new number with the power 10 of 9, the one I wrote in red, I'm going to add 0.41. And you can see now I had 2.71, my final answer, 2.71 times 10 to the 9 power, people. And that will be the total population between India and Pakistan. Okay, let's go to problem number 5. Here is question number 5, and in question 5 here, this is not a word problem, it's just a regular subtraction problem. Find the difference. Again, I'm going to do problem number 5 with different numbers. So in the original problem, look at the numbers that they gave you in scientific notation. In mine, look at mine. The first number will be this, okay? This one that I'm highlighting. And the second number they gave me is this one that I'm highlighting in blue, okay? Now, first thing you're going to do is you want to make sure that before you add and subtract numbers in scientific notation, make sure that the power of 10 have the same exponent, and they do have the same exponent, both of these numbers. So once you know that, take your regular calculator, and the only thing you're going to do is subtract the numbers that are not powers of 10. And the one from yellow will be negative 0.83. I'm going to subtract from the one in blue 3.1. And you can see I got negative 3.93. And then don't forget that this answer must be in scientific notation, because if you subtracted two numbers in scientific notation, your final answer has to be in scientific notation. And that's how you do question number 5. Let's go number 6. So in question number 6, what we're going to do is the same thing. It's a regular subtraction problem using scientific notation number. However, before I subtract, I need to make sure that the powers of 10, they both have the same exponent. By the way, this is 14, not 4. Okay, so when you look at the exponents, they're not the same. So we're going to have to fix one of them. Or do I fix the one in blue, the number in scientific notation in blue, or do I fix the one in yellow? Okay, so which one you will fix? In this case, I'm going to fix the one in yellow, okay, because if I want to make the 14 into a 12, it's going to be much easier to move the decimal point to the right than to the left, because I will get a really small number. I don't want to get a really small number. I usually want to get a number between 1 and 10. Okay, I want to avoid decimals as much as possible, really small decimals. So what I'm going to do is I'm going to take the decimal point of the number in yellow, 0.05, and I'm going to move it to the right 2 times. So now the decimal point is here. So I'm going to have 5 point times 10. Now, when I move the decimal point to the right, what I'm doing is I'm subtracting from the original exponent. I move it twice to the right. I'm subtracting 2 from the 14. So now my new number is going to be 5 point times 10 to the 12 power. And you can see now that we have now the same exponent in each power of 10 between the 9.7 times 10 to the 12 power and the 5 times 10 to the 12 power. When you have the same exponent for the power of 10, take your calculator, work with the numbers that are not not powers of 10. So the 9.7 from the blue, and I'm going to subtract the 5 from the one I wrote in red. You can see I got 4.7. So my final answer here is going to be 4.7 times 10 to the power of 12, because that was the exponent in common. And that's how you do problem number 6. Let's go 7. So here's question number 7, and here we are adding 2 numbers in scientific notation. Remember, the original problem that you're going to see in the quiz is going to be a little bit different than the example I'm showing you. I'm just using different numbers, but the process is still the same. Okay. Remember, to add and subtract numbers in scientific notation, the power of 10 must have the same exponent. And you can see we don't have the same exponent. One is 11, the other one is 12. What does that mean? I'm going to have to change one of these scientific notation, the exponent, or one of these numbers in scientific notation, so it becomes the same as the other one. I prefer taking, let me see. I prefer taking the 6.41 times 10 to the 12 power. I'm going to move the decimal point 1 time to the left, because I want to make the 12 into 11. So now I'm going to have 0.641 times 10. And when you move the decimal point to the left, we are adding 1 to the original exponent of the power of 10. So now this is to the 13. When you move the decimal point to the left to fix the number, okay, you're adding to the original exponent. When you move the decimal point to the right, you're subtracting from the original exponent. Now that I have, oops, I did something wrong here. I didn't want to move to the left. My bad. Let me fix that. Okay. Because if I move it to the left, then it's going to be 13. I want to make it to the 11th power. Okay, so what I'm going to do, instead of moving the decimal point to the left, okay, I'm going to move the decimal point to the right. Okay, and now thinking about it, you know what? I'm not going to change the second one. Let me erase this. So my apologies, because I'm not thinking before I'm acting or writing. Okay, I'm going to change the 5.53 times 10 to 11 power, the exponent 11. I want to make it exponent 12. And what I want to do is I want to take the decimal point of 5.53 and move it to the left. So now I'm going to have 0.553 times 10 to the 12 power. Because when you move the decimal point to the left, you're adding 1. Okay? If you move the decimal point to the right, you're subtracting 1. Okay? Now that I have the same exponent from each power of 10, now I can take my calculator, okay, and take 0.553, that's the number I fix, and change it to get a power of 12, exponent 12. I'm going to add the 6.41. And you can see I got 6.963. So my final answer is 6.963 times 10 to the 12 power. Okay? So that's how you do number 7. Let's go to the last one, number 8. Very similar like I did problem number 7. Okay? I want to make sure that the 10s, the powers of 10, they have the same exponent. They don't have the same exponent. You can see one is 6, the other one is 7. Okay, I usually want to make the bigger exponent to the smaller exponent. But honestly, it all depends on the problem. Okay, but in my case, I'm going to take the bigger exponent. I want to make it to a smaller one. In fact, the other way around, I want to make the smaller one to the bigger one. And what I'm going to do is I'm going to take the 8.31 times 10 to the 6th power, and I'm going to move it one time to the left. Remember, when you move to the left, you're adding to the original exponent. So if I move one to the left, I'm adding 1 to the 6 here. So now my new number is 0.831 times 10 to the 7th power. And now that I have the same exponent 7, see, in the powers of 10, now I can take my calculator and now I'm going to add the numbers that are not powers of 10. So 0.831, I'm going to add the 7.9. And you can see I got 8.731 times 10 to the 7th power. Okay, and that's how you do problem number 8. Remember that I changed the numbers so you can try on your own this exercise following my example. Okay, I hope this helps.